Thank you.
Thank you so much. So, and first of all, hello to the amazing Portuguese InfoSec community. It's a pleasure to speak here. And the very first thing that I want to say is thanks a lot to all the organizers. You are doing an amazing job. Thank you so much. All right, and to kick it off, it's about Pentest Deep Dive. We are looking at a cloud backup software. Maybe you read it already on the schedule. And just to tell you a little bit about me. So I'm a technical project manager, team lead at Cobalt. We are pen testing as a service company. So we are doing pen tests using a freelancer network of around about 270 pen testers. And I'm one of them. In my free time, I'm doing pen testing. In my day-to-day, I'm leading the operations department. And I'm also an information security researcher. I'm a pen tester. I'm a public speaker. I'm usually speaking at InfoSec conferences, sharing my research. Yeah, and I have around about 9 years experience in information security. So, and let's see what is on our to-do list. So on our to-do list today is, since it's the whole story of a pen test, it starts with the scope. It continues with Reconnaissance. Then it goes to the exploitation part, the fun part. And then we are looking a little bit into remediation. This will be a little bit more generic, and then I'll keep it open for questions. And I hope you do have some. So let's start with the disclaimer. That's the boring part. I'm sorry. So Cobalt doesn't share any vulnerability information or publishes any vulnerability for information. The following content that you will see is all my research and is not associated to Cobalt at all. The company that I'll talk about in the next few seconds was contacted, and they have access to all vulnerability details. Unfortunately, they didn't really care that much. So I didn't get a read receipt. Nobody replied. So responsible disclosure was attempted. Unfortunately, it didn't work that way. So let's have a look at the scope. And we are talking about Vulnerable Limited. So that Vulnerable Limited is a company. They deploy their AWS, their internal network in AWS. Most of my clients nowadays, they really like to go into cloud because cloud is hip, cloud is cool. Everybody loves that. And it's also easy to manage. You can scale as you grow and stuff like that. You don't have to buy servers. That's all the stuff that you have to buy stuff and you have to put money on it. That's really cool on AWS. So the client was particularly interested in checking out assuming that attackers gain access through a compromised web server. We have a web application there that can be anything. That can be an online shop. That can be, a newspaper site or some content management system, maybe a WordPress or something. So, and imagine that gets now compromised. That web server is deployed on your internal network, so and externally reachable. So with access on that web server, you can now spread out through the whole internal network. So it's essentially an internal network assessment on the cloud, basically. So, and the goal of the assessment was to get access to sensitive data, as always. So, and how do you do that? You start with Reconnaissance, and the one thing that is pretty cool when you're dealing with pretty large internal networks, you want to get something to look at pretty soon. So you start, of course, with Nmap. I mean, everybody starts with Nmap. And then you start with Equitone to get some screenshots, to get pictures that you can look at where you can easily spot, okay, that's a Tomcat, and if we see a Tomcat, I think everybody here tries, of course, the default credentials, and in 99% of the cases it works. It was not that easy at that time, and of course we go with Metasploit just to go with the really, really, really low-hanging fruit, Eternal Blue usually always works, and that's how it started here also. And that's a cool map that Equitone actually then generates when you do that Equitone scan. So it you see hotspots, and they are similar. So when you have hosts here grouped by, and it's a little bit more bold here, then you see they are related. So they might share the same software components. They might be all Tomcat servers, or all WordPress servers or something. So it's a little bit cool grouping. And it's kind of fancy. I mean, I like it. And yeah, then it gets also a little bit more into detail about the actual services that are found. So you can then scroll through and look at the services. And yeah, that's the thing that we'll talk about today. It's the Samanda Management Console. And the Samanda Management Console, when you look at it, I think it feels a little bit like the really early days of the internet. They could use a designer, I think. And so it's built on Apache, and it's really, really legacy. So, and that's also something that Aquatone actually really does a good job at. So it displays you like the HTTP code, it displays you this web server that is used, and then some components that web server is using. You can, of course, then dive into details, like it captures also like the HTTP request headers and stuff like that. So if you want to get a little bit more into that, you can do that, but it's not really needed at all. That picture already caught my attention. And now you have it a little bit bigger. So that's basically the login interface. You log in with a username and a password. Then you have some checkboxes that you can check to automate some of the actions when you log in. And then there are some links to their forums and stuff. And yeah, that's basically the login page. So, and just to have a little bit of this explanation what that actually does. So the Samanda Management Console is actually the management interface of Samanda Cloud Backup. And Samanda Cloud Backup is a software solution to back up your internal network to various cloud backup solutions. Yeah, you can back up to S3 buckets, you can back up to Google Cloud, you can back up wherever you want, basically. And Samanda is basically automating that. So, and obviously if you want to upload all of that data to the cloud, you have to get that software access to your cloud credentials. And that's the juicy part. We'll look into that later. So, but first of all, let's just Google. So we Google a little bit for it and have a look. Are there any default credentials? Because that's usually the first thing that you do when you see like a login form. And you're always wondering, did they actually change the default credentials? And yeah, of course not. So the default credentials are admin. I think that's very creative. And so they also documented on their public documentation, so that's pretty cool. It's basically the first Google result. So, and after trying them out, you are basically in, and it looks like that. So then you're basically going through that and have a little look about what's available here. And of course, you're looking for secret keys. You're looking for all sorts of configuration files. You're looking for features that are interesting, like stuff like, can you maybe execute commands? Can you maybe load configuration files? What about like reporting? Can you export something? Are there maybe CSV import export features? Can you generate PDF files, stuff like that? Because you always have to remember that thing is deployed on the cloud. And it has the ability to speak to a AWS metadata endpoint, and then you can extract even more keys. So even more keys than the keys that you already got access to right now. So now you already have some cool AWS secret keys. You import them to the next tool that you have to evaluate a little bit what you have access to. Maybe those keys allow you already to execute code, if you're lucky. In that case, I was not. But yeah, you're going, of course, a little bit further, and you want to look a little bit what other features are available. So there was a cool feature that's in the advanced tab of it, and that feature allowed to execute comments. I think that's some sort of debug feature that they want to have, and it's also very dangerous. So you see, it's like experts only. And since I'm an expert, I looked at that, of course, and they also they display like behind there only non-interactive comments are allowed. That's very boring. So you don't only want to get restricted to the comments that you can execute here. And I was thinking, okay, what happens if I provide different input? And first I was a little bit sad because it didn't work that way, and I could really only execute the comments that were whitelisted there. But There's always another way. So what happens if you pipe the output of a comment into another comment? What gets then executed? And you see here, the second comment gets executed. So that's cool. But the second comment is actually not even whitelisted. So that's working now. But what happens if you do something like that? So now you have a curl request that requests the secret keys of that AWS metadata endpoint, and that's not even allowed. Curl, you can't even access curl because that's not whitelisted. So now you have access to even more secret keys. That's cool, but you want to get code execution, like real code execution. And how do you do that? Well, you build some sort of crap comment that you put in front of, like you would echo like an A or something, or whatever character you want to have, something that you can just ignore. And then you pipe it basically into like something that creates your reverse shell. And in that case, it's like a Python comment. I'm sure there are like 200 million other ways to do that. That's just the most reliable, and it worked perfectly. So if you execute that, you get a nice shell. And now you have basically access, code execution access on that Savannah Cloud Management backup server. And that's pretty cool now. So, but the thing is, you're a little bit limited. I mean, there are default credentials. What if somebody changes them? That's pretty sad then. And you also can't really automate that attack. That's also not cool. So, but maybe if they don't change the default credentials, you can automate it some sort. So there are some prerequisites, like for example, you have to know the IP address of the server. That's also something which is not ideal if you want to automate it and weaponize it. You have to rely on that they changed, that they didn't change the default credentials. Something that usually really works because nobody does that. And if you chain it all together, you can basically log somebody in because you can't really rely on that the user that you social engineer is actually authenticated. Often the case is that you target some sort of network engineer that has no simple clue about that service. So you want to make sure that just by clicking on a simple link, that network engineer with access to the internal network compromises that server. So, and you have to rely on default credentials now, and you have to know the IP address. Otherwise, then it's working really cool. So the proof of concept and write-up is available on GitHub, like not right now, but seconds after the talk. But now we are talking a little bit more about automating stuff. So knowledge of the IP address. Now that's a little bit of a tricky one. So you want to have like a proof of concept that scans your whole internal network for IP addresses or hosts that are active. And then basically checks if those servers that are up are basically Samanda cloud management software, hosting cloud management software. So how do you do that? So there are some cool guys that really do amazing research around that, like Skylance or Matthew Ulm. Matthew Ulm developed something called JSRecon. That's a pretty cool tool that allows using WebSockets to scan the internal network. And you can, it works with basically with timing attacks. So you can, you can build up like a WebSocket connection to an arbitrary port. And depending on how fast the ready state changes, you can guess if that's open, if that's filtered or closed. And that's all you really need to know. Because once you know that service is actually online, you can start with just picking any file, any static file that you can find on that website. Maybe the logo. The logo for Samanda works just great. Or any other picture or file that is pretty unique to that service. And then you hard code that in. And then you set up, no idea, you can set up like an iframe or an image tag to it. You set like an event handler to that. And let it call, let it do something if it creates an error or not. So, and if you do that, that works pretty amazing. And I have a little demo how that's working for IoT cameras. I hope that the video is actually loading, and it is loading. Nice. So that's my prior research about IoT devices, and that's basically me implementing that whole attack for IoT camera. It's an HTTP request-based vulnerability. It's a common injection. And you see now the network is scanned in the background. Once the device is found, the malicious request is fired, and now you got code execution. Let's wait a little bit until the telnet service is up. And there you go. So that's the cool thing now. Since when you keep that in mind, you can weaponize every single IoT attack that is like HTTP request based. So like if it's a GET request, if it's a POST request, doesn't really matter. You build that using WebSockets. You build some sort of fingerprinting in there. So you can even have like a whole attack framework here. You can build that for IoT devices, like in this case it was a CCTV camera. You can build in there like the Samanda backup management software, and you can, like, if you build modules for that, you can have a pretty nice attack framework where you just have to trick somebody to visit that site. So maybe you noticed it in that video that the only little downside with that is that once that scan is running, if you have a large network, that takes time. So, and you have to trick the user into actually doing something that doesn't bore them. So you have to provide them a video or a song or something that they read. Imagine you can also combine it with a cross-site scripting vulnerability and combine it with a watering hole attack. Maybe you know that your network engineers, they read a specific newspaper every single morning or something like that, and you find a web application vulnerability there, you inject that malicious JavaScript code. Yeah, and it's running in the background. Usually they probably won't finish the article in like 10 seconds, hopefully, if it's interesting. So, and if they stay long enough on that, that is totally enough to scan your network. So, then getting to the remediation advice here, I mean, always changing your default credentials. I'm sorry, that's not rocket science, but it's pretty obvious and still people don't do it. Then a patch management policy would be really, really helpful. So if you deploy some weird cloud management software on your network, make sure that you actually patch it. That's always a nice recommendation too. And then I think the last one is pretty cool, that you can actually ask for Pentest reports to every single time that your company purchases software or they want to deploy something. Like push them and ask them for their last Pentest report. Did they ever do like a security assessment? Did they ever try to show if they actually care about security? Make it part of the whole sales process. So if you want to buy a tool, tell your procurement department, if there's no Pentest report, I'm sorry, we won't buy. And that would be a cool idea already. And then don't only request the Pentest report, send it to your security guys or to somebody who knows it and let them interpret the Pentest report. If that's looking really, really bad, maybe consider another vendor. There are so many. You don't have to go with the first one. So yeah, and that's basically it. If there are any questions, I'm more than happy to answer them.